instrument pilot, you'll use VOR navigation to fly direct routings to VOR stations and to navigate along those electronic highways in the sky, the IFR airways. You'll also use your VORs to fly instrument approaches to airports, which we'll talk about later. Now, you've probably been using your VORs quite a bit already in your VFR flying. But because you'll now be flying in the clouds, and because IFR airways sometimes have you flying in a valley with mountain peaks on either side, it becomes really important to know exactly where you are and to fly a precise course along an airway. And of course, you have to continue to scan your flight instruments so the plane stays right side up while you do your navigation. First, let's review how you know exactly where you are now. Let's tune in the Julian VOR. I'll tune in the frequency of 114.0 and identify the station. That's to be sure it's on the air and I didn't misdial the frequency. Then I'll turn the OBS knob to center the needle with a from indication. Now, be careful that you don't turn the knob too fast, or it'll seem like the needle has a mind of its own. The needle centers with the OBS on 235, so I'm on the Julian 235 radial. That means I'm southwest of the station. Now that I know where I am, I'll turn the OBS and center the needle with a 2 indication. And the OBS now reads 055 degrees. Of course, to have the needle indications make sense, the OBS must agree with the general direction that you're flying. And I'll be flying northeast to go to the station. As you know, tracking a course is simply an exercise in holding a heading. The VOR CDI needle just lets you know when you need to take up a new heading, say to better correct for the wind. In this case, the course over the ground that I want to track is 055 degrees. But I know from my weather briefing that I've got a crosswind component from the left. So I'll start out with a heading of 050 degrees and see how it works. The amount of crab I need depends on the wind speed and direction. Of course, it does help to know in advance what the winds aloft are in the area. Now, the needle's moving ever so slightly to the left, so that means I need just a few more degrees of crosswind correction to the left. I'll try 045 degrees. Now, resist the temptation to turn the OBS to center the needle. That could end up leading you in a big curving path around the station, and that's certainly not very precise navigation. The needle's coming back to center, so I'll pick up a new heading of 047 degrees. Notice that I make smaller and smaller corrections until I get the wind figured out, and then I won't have to make many corrections at all. Now comes the fun part, seeing how quickly you can detect needle movement and make small corrections to center it again. Here the needle has started to move to the left, so I'll turn 2 degrees to the left towards the needle and then hold that heading.
The trick is to use small corrections, but make them as soon as you see the needle moving. Don't wait until you have a big deflection. That means a big correction and lots of work to get back on course. Now, how often do you need to check the indicator needle to stay on course? Well, you'll find that distance from the VOR station will have a lot to do with it. As you already know, your VOR tells you your angle off course, not your distance off course. So as you get closer to the VOR, you'll get more needle deflection and more rapid needle movement for the same amount of distance off course. As you become more experienced, you'll develop a feel for how fast the needle is moving, and you'll automatically step up your scan to include it when you need to. Now, I've been tracking this radial pretty well, if I do say so myself, but notice all of a sudden the needle is moving all the way to the left. Well, what's happening is I'm getting pretty close to the station, so just a little bit of deviation in my course shows up as a large needle movement. I don't want to chase the needle here, because if I do, I'll end up making myself sick. As you can see now, the needle is all the way over to the left side, And now it's moving back the other way, clear to the right side. And the flag went from off, and now it shows a from. And we have station passage.
Now that I've passed over the VOR to the northeast, I'll turn left and use Victor 458 to fly west to the Oceanside VOR. First, I'll turn the OBS to 263 degrees, because that's the radial that defines the airway I want to fly. Next, I'll turn left to a heading that matches my OBS, 263 degrees, so that the needle will give me the proper indications. Now the needle shows all the way to the left, and the to from indicator shows from. Now with the needle all the way to the left and a heading of 263 degrees, I would never intercept the 263 degree radial, unless the wind blew me over there. So I'll turn to a heading that will intercept it. The further you are from a station, the bigger the intercept angle you'll need. Sometimes you might even use a 90-degree intercept angle. Because we're pretty close to the station, I'll start out with a 45-degree intercept angle.
And to help me, I'll use the 45-degree mark here on my heading indicator. A heading of, about 220 degrees should do it. Left is clear. Now I'll hold this heading until the needle starts to move. As soon as the needle starts moving, you want to start reducing your intercept angle. And the faster the needle's moving, the quicker you need to reduce that angle.
Now that the needle is centering, I'll set up a heading to correct for the crosswind. I'll turn to a heading of 268 degrees. That's my desired course of 263 plus a 5-degree right wind correction angle. And then I'll track the radial as before. And I'll keep an eye out for the results of my crosswind correction. And that's all there is to it. A little patience, a few small corrections, and you'll be precisely flying these highways in the sky, even when you're solidly in the clouds and you can't see the ground at all.